All right, let's look at the section 5.1, example 2. All right, so we want to prove that if f is a linear transformation from plane P to itself, then f preserves non-collinearity. All right, so let's start with the given. Given is f is a linear transformation. All right, so we know that. Right, so since f is a transformation, it has to be at least onto. So we know that f of plane P is going to be mapped to the entire plane P. Right? All right, so let's try to use the proof by contradiction. So we're going to assume the opposite of what we want to say. So let's assume that f does not preserve non-collinearity. Right? If that's the case, we know that we should be able to find the three non-collinear points, like the picture here, A, B, C, that are mapped to collinear points. Right? So let's write that down. So we know that there exists three non-collinear points, A, B, C, such that their images are actually collinear. All right, so that's the picture here. All right, then we know this. Since A prime, B prime, C prime are all on the same line, line A prime, B prime, and the line B prime, C prime, line A prime, C prime, are all on the same line. So let's call that the common line L. All right, so which means that all three lines AB, BC, line AC are all mapped to the same line L. Right? So we have that. All right. So we now we at least know that all three lines are mapped to a single line L. Right? And what we want to say next is we're going to show that the entire plane is actually going to have to be mapped to a single line. All right, so I'm going to pick a point. Let's put a random point outside those three lines. So I'm going to put a point, let's see, how about that? All right, I put a point here. All right, so let's just say I'm going to choose any random point outside these three lines. All right, we have that. And then we know that there's going to be a point between A and B. So let's call it E. So let's draw a picture. E is going to look like something like that. Right? Then the next would be I'm going to draw a line using P and E. So if you draw a line which looks kind of like that. All right, so let's see. Then you can see that once you have a line here, right, there's going to be either PE is going to either intersect line BC or line AC. And you can quote the postulate of Pasch, but we know that there's going to be an intersection here. So let's call that intersection, we have to name it something, right? So let's call it F, right? So let's write that down. Let's see. So we're going to have, so line PE, sorry. Line PE meets line AC or line BC. So depending on the location of P, if P is over here, it's going to intersect AC. Actually, if it's not parallel to BC, it's going to intersect BC as well. All right, but anyway, it's going to intersect either one. So that intersection is called the F. All right. With that construction, we know that, E, so let's say E is on AB. So we know that the E prime is going to be mapped to, it's going to be on the line L, right? And then F is on line BC, so its image is going to be on the line as well, right? Since F is a linear transformation, P, F, E are on the same line, So it's going to be mapped onto the same line, which we can conclude that the P prime is going to be on the line L. So that's the conclusion here. So we know that the P prime is going to be, of course, the line E prime F prime, but E prime F prime is going to be the same line L. So P prime is going to be on the line L, right? So we picked any random point P outside those three lines, and we found out that its image is going to be on the same line, right? Which means that here, the image of the entire plane P is going to be a single line L, which is a contradiction because remember that F is a transformation which requires that it's onto. So F of plane P is actually has to be the entire plane, but instead we just got a single line. So that's a contradiction there. Right, so therefore we know that F preserves non-collinearity. All right, that's it. I hope that this was clear.